This is the last question on a paper from 2016 from the 4MAO Edexcel GCSE. And it's a geometry problem. A lot of candidates, to try and find the area of this pentagon, they started with their first step as to draw a line there. Not particularly sensible, I'm afraid. That makes it really hard to solve. You can continue like that. It is possible, but it's very difficult, and it requires you to also extend lines down from here down to this point here with a right angle up there. But you end up dividing the pentagon into four shapes, sort of three triangles and a rectangle, and it just gets nasty, especially because you don't know how much of this 105 is spread between, is this angle and the one above it. So it's hard that way. So I recommend instead to divide it up like that. And you end up with two congruent triangles, this one, and something else in the middle. But that middle triangle is isosceles because of the symmetry of the shape. Okay, we're going to kick off by working out the area of these two congruent blue triangles. For that, we can use this formula from the formula sheet. Area of a triangle is half AB sine capital C. Now, you can use this formula when you have what I call crocodile jaws information for a triangle. Now, the technical po-faced version of crocodile jaws information is to say that you have two sides and the included angle, or the angle in between. But I prefer it to be just called crocodile jaws, because imagine there's a crocodile over here with its eyes somewhere over here, and it's looking to the right, and its top jaw is up here, it's 12 centimetres long, its bottom jaw is 8 centimetres long, and it's opened its mouth really wide to 105 degrees. Hopefully you can picture that crocodile in your head. And of course there's another one over here pointing to the left. When you have crocodile jaws information, you can use this formula, and you can also use the cosine rule, provided you label up the triangle slightly differently. So if we label up this triangle, look in here, there's only one angle, isn't there? We take sines, coses and tans of angles, so this must be an angle here. So that's your C, so C is here. And then A and B, oh, by the way, that would make little c, this side of the triangle. And your A and B, it doesn't really matter which way round they are. So I'm going to choose my A as 8 and my B as 12. So substituting those in for that left-hand triangle, half A, B, sine C. And then I'm going to double it, because we've got two such triangles. I'm going to stick that in my calculator, and we get 92.7. I've written down a few extra decimal places, because we're going to need that number later to add to the area of the middle triangle, and I don't want to lose accuracy to 3 sig figs, as they want the final answer. So don't round it off to 3 sig figs yet, until the very end. Okay, right, let's think about the central triangle. We first need to know these lengths here, and as I mentioned before, you can use cosine rule for that using the crocodile jaws information for this triangle. Now I'm going to call those lengths both x, and cosine rule is in the formula sheet. Now, to label up the triangle this time, again, looking at cosine rule, where can you see any angles? Well, oh look, there's only one angle in the cosine rule, so that must be this angle. So this time, this must be capital A, this point here, and the x must be little a. And then again, your 8 and your 12 are interchangeable between B and C. So A is x, B is 8, C is 12, and capital A is 105, and that whole right-hand side of the equation in the calculator gives us just over 257. Square root it, and we've got x as 16.05, etc. centimetres. Now I've still got that number stored in my calculator. I'm going to use it as the answer button in a moment. So how are we going to use? We've got an isosceles triangle. We know all three sides of our isosceles triangle. How are we going to find its area? Well, it's possible to actually apply cosine rule again to find an angle, and you could find, say, this angle down here or this one up here, and then once again use half AB sine C to get the area of that triangle. But that's complicated, and you can probably judge by the amount of space I've left myself on the screen that I'm not going to do all that. It's much easier to extend a vertical down there We know this length here is 6.5 because it's half of 13. And then we can just use Pythagoras Theorem to work out the height of this isosceles triangle. And then we can use half base times height on the triangle, the original old-fashioned area of a triangle formula to find the area of that isosceles triangle. So first let's find, I'm going to call it h, this height here, using Pythagoras. Just label h on there as well. So it's sort of reverse Pythagoras, isn't it? We know the hypotenuse, x. We don't know one of the shorter sides. So we need to square and subtract. That gives, just using our previous value of x, which is stored in the calculator as the answer. So I've typed into my calculator answer squared, take away 6.5 squared equals, and then square root answer equals to get this 14 point, etc. Great, we have now our base of this isosceles triangle, and we have the height, 14 and a bit. So I'm going to use some colour in that triangle red, so I can talk about it as the red triangle. Look over here, I'm going to add to my list of formulas half base times height for area of a triangle. That's what we're now going to use. So it's the red area is a half times the base, which is 13, times the height, which we just calculated, and in the calculator that gives us just over 95 square centimetres. Okay, we're pretty much done. We just need to add together a 92 and a bit with a 95 and a bit to get our total area, which rounds off to 3 sig figs to 188 square centimetres.